Hello, this is Ms. DB, and in this video we'll go over how to do some of the problems in the Chapter 5, Section 3 worksheet on medians and altitudes of triangles. So be sure you've read the information in your book for more examples and more background, and then we will be applying properties of medians and altitudes to find missing measures. So here we have a median. A median of a triangle is a segment whose endpoints are a vertex of the triangle, that's one endpoint, and the midpoint of the opposite side. So you need to know the midpoint of one side, and then you connect that midpoint to the vertex opposite it. That's a median. If you make the medians for every side of the triangle, that point where they all intersect, the point of concurrency, is called the centroid. Things will balance. If you put your finger right there and hold it up, it should balance right there, the centroid. So how many medians does a triangle have? You can figure that one out for yourself. Explain why XC is a median. So look back at the definition and say why this is a median. And then it asks you to name the other two medians, and then what point is the centroid. That'll just be a point. So that's just some checking to see that you understand those vocabulary terms. The centroid, P in this case, is 2/3 the distance from each vertex to the midpoint of the opposite side. So BP here is 2/3 of this whole segment, BZ. If you were to take BP and divide it into 3 parts, BP gets 2 of those parts, and BZ gets only 1 of those parts. So BP is 2/3, and PZ would be 1/3. So the centroid one is a little different than the other theorems we've looked at. So in number 5 through 8, we're going to be looking at this figure over here, triangle RSQ, QRS, I guess, and they give us some information. They say that Rx is equal to 48, and that is a median. And we know it's a median because it is a segment that goes from the vertex of the triangle to the midpoint of the side opposite. So the median is going to be divided, this is the centroid here. So remember that this is 2 parts and this is 1 part. So if you can think about 48 divided by 3 is equal to 16. And that means that each of these pieces is 16. So if they ask us to find WX, that's 16. If they ask us to find WR or RW, that would be 32. So you can break its length into 3 pieces, and then you can 2/3 is going to be the longer section, and the shorter one will be 1/3. So for QW, let me erase this here. For QW, that is also a mid segment here, and the median, sorry. The median is from the vertex of a triangle to the midpoint of the side opposite. So QW is not the whole median, it's only part of it. So QW is 30, not QZ. But we know that 30 is 2/3 of the way up from Q to Z. So if this is 2/3, 1/3 plus 1/3, that's each 15, then we know that WZ is also 15. So you could write an equation and say that QW is equal to 2/3 of QZ, and then you could put in that 30 is equal to 2/3 of QZ, and you could solve this by multiplying both sides by the reciprocal, and you'll get the right answer. Or you can also think about this as being divided into thirds and then finding the parts that you need in order to answer the questions. So if they ask you for WZ, now you know that it's 15. If they ask you for QZ, it would be 15 plus 15 plus 15, which is 45. So you should be able to find all the parts in that way. All right, so in this next triangle we have triangle HJK, and we have that JE and CK and HD have all been drawn, so this is the centroid here. So we know that this point is 2/3 of the way from JE. JB would be twice as big as BE, and HB and BD, and so on. So let's see what we got. We've got HB. They want us to find that. Oh, here they also give us more information. I was going to say there's no information. We know that HD is 21. This whole thing is 21 from here to here. Well, 2/3 of 21, that's HB. So what's 2/3 of 21? We'll break 21 into thirds, 7, 7, and 7. Two of those, 7 plus 7, that's HB. And this one would be 7 then. 14 plus 7 is 21. So you can answer those two. We are also given that BK is 18. This piece here is 18. Well, 18 is 2/3 of the whole length of CK. So let's see, this could be 9, and this could be 9, and then this would also be 9. So CK, that's the whole thing, would be 9 times 3, or 9 plus 9 plus 9, and CB is marked as 9. All right, now to find the centroid, and again, that's the point where it's going to balance. So you would hang something from that point if you were going to hang it up, or there's other reasons you need to know the point of balance. So what you're going to do is, whoops, here we go. We need to know the midpoints of the sides, and we're going to connect the midpoint to the vertice opposite. So we only have to do it for two sides. The centroid will be the intersection of all three, but if you have two of them, you'll be good. So here's another mobile, and the chain is supposed to hang from the centroid. So you need to find the midpoint of two of these sides. It doesn't really matter which one. They didn't line it up really nice for us along the axes. So to find the midpoint, let's do the midpoint of BC. You'll take the x coordinates and add them together and divide by 2, and then take the y coordinates. Hey. I'm going to try that again. Take the x coordinates, add them together, divide by 2. So 5 plus 7 is 12, divided by 2 is 6. So it went away, but it's going to be 6 something. Our x coordinate will be 6. And then our y coordinate is going to be halfway between 0 and 4 divided by 2. So that would be 4 divided by 2 is 2. So the midpoint is going to be at 6, 2, which is right here. Right there. So I'm going to go ahead and insert a shape at 6, 2. That won't erase itself. So 6, 2. Now, I also need to have in addition to knowing that that's the midpoint, it needs to be it needs to connect over here to the vertex. So my shape there, I don't have to know the slope or anything. I'm just going to go ahead and draw a line from the midpoint at 6, 2, so about right there, to the vertex opposite. So it's that straight line right there. Now I have to repeat this for another side. So the midpoint of side, let's do side AC. So to find the midpoint of the x-coordinates, you'll take 0 plus 5, those are the two x-coordinates, and then divide that answer by 2. So that would be 5 divided by 2, which is 2.5. And that's the x-coordinate of the midpoint. The y-coordinate of the midpoint would be found by taking the y-coordinates, which is 2 for A and 0 for C, and then we divide that by 2. So that's equal to 2 divided by 2, which is 1. So the coordinate of the midpoint of, what are we on, AC, would be 2.52. Midpoint of AC. Okay, so find that point, and I'm going to draw a line. And I'll draw a line from that point. 2.5 is right here, and 2 is, whoa, that can't be right. 2.51. 2.51 is right here. And I have to go from there up to the vertex opposite it. So I've drawn my two lines, and it looks like they are crossing. I have to fix this. This is supposed to be 1. It looks like they're crossing right here at the point 4, 2. So this might erase, but I can get it to go there right now. So that looks like the point where the two medians are intersecting, so that would be the right place to hang your mobile from. You still have to write that. Okay, then we're going to learn about altitudes of a triangle. An altitude is the perpendicular segment from a vertex to the line containing the opposite side. So it's how high your triangle is. And there's 3 altitudes. You can make one for each side of the triangle. So it's always at right angles to one side, and then it goes to the vertex opposite it. The orthocenter is the point of concurrency where all of those would meet. There's no good theorem that goes along with orthocenter. You can find the orthocenter, but it doesn't really give you any information about lengths of sides or angles or anything. Alright, so you're going to name the altitudes and the orthocenter here, just some vocab checkup. And then all we'll do for this type of orthocenter is basically find the orthocenter. So we have to find the altitudes, and we need at least 2 of them, and then find the point where they intersect. So in this triangle, we have to find the equation of the line containing the altitude from G to FH. So FH is a horizontal line, so I know that the altitude of this is going to be a vertical line. So I can draw a nice vertical line that will be at right angles, because a horizontal and a vertical line are at right angles to each other. And I'm going to make it so that it goes through G. So there is my the line that altitude from FH to G. Now I need to also find another one. So they suggest finding the equation of the line containing the altitude from H to FG. So they want us to find the equation of the line that would go from H to FG. So to find that, I need to know the slope of FG, because I need to know what its slope is, because perpendicular will have the slope that is opposite reciprocal. So the slope of FG is, let's do a rise over run thing. Let's do it here. It looks like it's 1. The rise is 2, the run is 2, so the slope is 1. So this one has a slope of 1. So the slope of the line I want to make is going to be -1. The opposite reciprocal of 1 is -1. So from H, I want to go, instead of going right 1 and up 1, I want to go left 1 and up 1. And then I want to keep that slope up. And that should then intersect FG at a right angle. So I'm doing a slope of -1. And let me get my line and make a straight line from H then. That's not a straight line. From H maybe because I have, there's the line. I guess it was just putting it over there. From H, and I want to go through all of those points as close as I can. Okay, so we have our 2 lines there, the blue one and the orange one, and you can find from the graph, you can find it, or we can do the equations. We can do this algebraically as well. So let's try algebraically. If we wrote the equation of the line containing the altitude from G to FH, this line right here, this is the line x equals 2. Vertical lines have the equation x equals whatever they go through. And now this line here, this blue line that I graphed, that equation is going to be in the form, we'll do y equals mx plus b. We know that its slope is -1, so I'll replace m with -1. And I can see that it's going through the y-axis right at, let's see, this is 2, 3, 4, 5. So its equation is y equals negative 1x plus 5. So I'm going to solve these two equations, x equals 2 and y equals negative 1x plus 5, to find the coordinates of this point right here and make sure I got it correct. So that means I'm going to use substitution and put x in here. So y is equal to negative 1 times 2 plus 5. So y is equal to negative 2 plus 5, which is 3. And the x is already given as 2. So this point should be at 2, 3 if I solve the equations, or if I graph it and I get the same thing for either one. So that's two different ways of doing this problem. Now you're going to repeat this for number 19. You can graph this on your own paper, or you can do it algebraically, but it does really help to have a picture of this. So try that one out and let me know if you need any help. All right, have a great day. Let me know if you